So in the question, how many solutions are existing to the equation? Okay, now we are having the equation 5x minus 2y is equal to 75. Okay, so it is the linear equation in two variable. Generally it is having infinitely many solutions, but we are having some condition that okay, x and y are integers and product of these two will be less than 0. Okay, so as we are having condition, so we are having limited number of solutions. So here okay, we have to convert the entire equation in terms of variable y. Okay, so y is in negative now. On transposing 5x minus 75 is equal to 2y. So on transposing we will get y is equal to 5x minus 75 by 2. So we wrote the entire equation in terms of y. Okay, now we know that x and y are integers. Okay, x and y are integers and x into y less than 0. That it means okay, that it means either x comma y, okay, either x comma y is negative. Okay, so out of these two one may be negative. Okay, now coming to the, if I take x value 1, okay, I'm taking x value 1, therefore y becomes y is equal to 5 into x na. So these are the multiples of 5. So 5 anja 5 minus 75 by 2. Therefore we are getting minus 70 by 2. Answer minus 35. Okay, now the solution set will be 1 comma minus 35. Okay, solution point. Now if I take x value 2, y is equal to, so multiples of 5 na, 5 2 is 10 minus 75 by 2. So minus 65 by 2. So it will become minus 32.5. But y value is in decimal, it is not an integer, so it will not qualify. Okay, so I'm taking x value 3. If I take x value 3, y is equal to 15 minus 75. So 15 minus 75 by 2. So minus 60 by 2. Answer minus 30. Okay, now when we observe the pattern, okay, when we are taking x value 1, okay, we are having 5 minus 75, so we are having even number. So 70 by 2, it is divisible by 2. So when we are taking x value 3, so we are getting numerator as even, therefore 60 by 2, so we are getting 30 integer. But when we are taking x value even number, when we are taking x value as even, we are getting numerator which is not divisible by 2. Therefore we are getting y value not an integer. So we have to proceed only the odd integers 1, 3, 5, 7, 9, 11 and so on. Okay, so we are continuing. If I take x value as 5, okay, now y is equal to 25 minus 75 by 2 minus 50 by 2, therefore minus 20. So I'm not taking even values here. X is equal to 6, so y is equal to 30 minus, no, we should not take even numbers na. So there is no need to take even numbers, so I'm cancelling. Okay, if I take x value as odd number, that is 7. So y is equal to 35 minus 75 by 2 minus 40 by 2. So minus 20. Here it is 25. Here it is 25. Okay. So x value 9. Y is equal to, okay, 45 minus 75 by 2 minus 30 by 2. Therefore minus 15. Now I am taking x value as 11. Y is equal to, so 55 minus 75 by 2 minus 20 by 2, so minus 10. Now if I take x value as 13, y value 65 minus 75 by 2 minus 10 by 2, okay, minus 5. If I take as x value some 15, okay, now we will get y is equal to, so 75 minus 75 by 2, okay, 0 by 2, which will become 0. Now 15 comma 0 on multiplication of these two, so 15 into 0, which will be equal to 0, but we should get multiplication of these two will be less than 0, so it is not possible. Okay, therefore the possible solutions are, okay, so 1, so we can write it. So it is the solution 1, solution 2, 3, 4, 5, 6 and 7. Now therefore there are 7 possible solutions to given equations. So you may have doubt that can we take any negative value for the x? So if I take x is equal to minus 1, therefore y is equal to minus 5 minus 75 by 2, so minus 80 by 2, so it will become minus 40. Now what is the x comma y point? Therefore minus 1 comma minus 40. So multiplication of these two will become 1 into 40, 40, negative into negative, positive. So 40. It will not be equal to or less than 0. Okay. Here 40 is not less than 0. Okay. So 40 is greater than 0. But we should get x into y should be less than 0. So we cannot take x value as negative numbers. When we take x as negative, we also get y as negative. So negative into negative will become a positive. So there is no chance of taking x as negative. So we are having 7 possible solutions to the given equation.